Application of derivatives is one of the most important real understanding part of mathematics. The applications are no doubt useful in our daily life. Few of the examples which are involved are increasing decreasing functions, Rolle's and Lagrange's theorem, maximas and minimas, tangents and normals. All of them which require some rate changes can be understood as application of derivative. One very simple application is rate of change. Rate of change of one variable. Say when we throw a stone in a lake or ponds, ripples like this will form. What we see, as radius increases, the area of the circle also increases. This can be taken as one case of rate of change. Another example, say a cone is there. Say this cone is filled with water at this level at particular time. Say this is the level of water in the cone. Suppose we make a hole here, water starts dipping at certain rate, say 3 centimeter cube per minute. Say the water is dipping. Now after some times water say remains to this level. Let us see what are the things which have changed. The area which has changed from this value to this value. Slant height has changed from this value to this value. Real height has changed from, vertical height has changed from this value to the lower value. Wetting surface area, the portion which was becoming wet, first was this, now this. Total surface area is also changing. Volume is also changing. So many things are changing at simultaneously. So when we consider the rate of changes of these things, we are going to study the rate of change of one variable with respect to the other variable. With respect to other variable. With respect to other. Now, for example, we continue with this problem. First say the radius was something. We have to calculate by how fast the radius increasing or decreasing, means dr by dt at the radius when the radius is say 4 centimeter. Now first of all, when we have to calculate dr by dt, we will make a relation between volume and r. Volume is 1/3 pi r square h. We cannot differentiate this until we do not have the relation between r and h, because if we want to calculate dr by dt and we are given dv by dt, we should have a relation only between v and r. So there must be some relation. Say it might be given that height is twice of radius. For example, this is given. So we will replace the height by 2r into 2r. So that will become 2 by 3 pi r cube. This is the volume at any instant with respect to radius. Now we are differentiating both sides with respect to time. Both sides with respect to time. So we will obtain dv by dt as 2 by 3 pi r cube will be differentiated to 3r square dr by dt. We always know that constants remain out of the differentiation. This cancels 2 pi r square dr by dt. So now dv by dt we are given. Now all the things we are given, this value we are given, this is a fact, radius we are given, so we can easily calculate the value of dr by dt. dv by dt we are given to 3 centimeter cube per minute. So 3 equals to 2 pi, r is 4 squared dr by dt. So 3 equals to 16 to 32 pi dr by dt. So dr by dt means the rate of change of radius with respect to time is 3 by 32 pi. centimeter per minute. The unit is always given by unit of radius to the unit of time. So this is example of rate of change of one variable with respect to the other. Another case can be if say you want to calculate area with respect to radius for a circle. Area is pi r square, dA by dr is simply 2 pi r dr, 2 pi r. So this is the case when one variable is changing to the other, we can apply differentiation to calculate its rate of change. If one variable rate change is given, we can calculate the rate change of the other variable.